Welcome to aminacademy.com. In material science and engineering, let us discuss about advanced materials. Advanced materials are new materials with enhanced properties that are intentionally used, designed for superior performance. The major scientific advances of the 20th century and a new understanding of atoms laid the foundation for the creation of advanced materials. It is the advances of the last 3 decades that have taken us over the conceptual threshold and are making advanced industrial materials and vital component of our high-tech economy. Advanced materials in 21st century. 21st century innovations are allowing scientists to manipulate substances like inorganic and organic at an atomic level and create new purpose-built materials that massively outperform naturally occurring materials. We have seen a huge leap forward in the last 3 decades, leading to the successful integration of advanced materials into high-tech manufacturing, medical procedures, and food production. What are advanced materials? Advanced materials is a complex scientific topic that covers a huge variety of fields and applications. Advanced materials defines advanced materials as a convenient generic term for new material that has been deliberately created by human beings. Modern understanding of how materials behave at a macroscopic scale was transformed by the understanding of how they are arranged at the microscopic level. In 20th century, scientists and researchers enthusiastically experimented with how to manipulate the arrangements of atoms and how to split the atoms. Advanced materials are beginning to transform every aspect of life. Previously, immutable assumptions about the nature of raw materials and their industrial potential have been swept aside. Design and manufacturing industries were previously limited by the characteristics of naturally occurring raw materials and the alloys and compounds we had created from them. Some life-changing innovations that depends on advanced materials and manufacturing research includes integrated circuits, that is IC circuit, magnetic data storage, liquid crystal displays, fiber optics, lasers. At a truly innovative level, advanced materials are enabling the invention of entirely new products and devices. Benefit of advanced materials. In general, benefits of advanced industrial materials are straightforward. They have the potential to bring us cheaper, more sophisticated, and more user-friendly products, household items, personal vehicles, and consumer durable are already improving our quality of life, saving labor, and enhancing recreations. We are also seeing similar innovations in the workplace. Advanced industrial materials are revolutionizing the devices, system, and infrastructure that previously defined and limited how we work and do business. One of the greatest emerging benefits of advanced materials is the dramatic improvements to our most basic needs, good health and food security. The 20th century delivered a revolution in medical care. More diseases become preventable or curable and more previously fatal. Injuries become treatable than during any other period of human history. The combination of new advanced biomaterials, inorganic advanced materials, and tiny, all driven smart devices will create a new generation of smart prosthetics that are effectively body part replacements. We are already seeing that nanotechnology applied to We will see about nanotechnology applied to topical cream that contains advanced biochemical materials as well as smart drugs that can be tailored for optimized individual therapy. Advanced materials and manufacturing can bridge that gap. Lab created advanced biomaterials and proteins for human consumption like 3D printed meats or another concept that is becoming commercially valuable. Now we'll discuss further about advanced materials. First is the semiconductors. Semiconductor is a substance that has specific electrical properties that enable it to serve as a foundation for computers and other electronic devices. It is typically a solid chemical element or compound that conducts electricity under certain conditions but not other conditions. Semiconductors have electrical properties that are intermediate between those of electrical conductors, that is metals and metal alloys, and insulators, that is ceramics and polymers. Furthermore, the electrical characteristics of this material are extremely sensitive to the presence of minute concentration of impurity atoms, for which the concentration may be controlled over very small spatial regions. Semiconductors have made possible the advent of integrated circuitry that has totally revolutionized the electronic and computer industries over the past 4 decades. Next, we'll discuss about biomaterials. Biomaterials may be natural or synthetic and are used medical application to support, enhance or replace damaged tissue or biological functions. The first historical use of biomaterials dates to antiquity when ancient Egyptians used sutures made from animal sinew. The length and the quality of our lives are being extended and improved by using biomaterials. In fact, in part, due to advancement and the ability to replace diseased and injured body parts, replacement implants are constructed of biomaterials, non-viable materials that are implanted into the body so that they functions in a reliable, safe and psychologically satisfactory manner while interacting with living tissues. That is, biomaterials must be biocompatible, that is compatible with body tissues and fluids with which they are in contact over acceptable time periods. Suitable biomaterials are to be found among the several classes of materials discussed. We will discuss later that also. And over the past several years, the development of new and better biomaterials has accelerated rapidly. Example of biomaterial application include joint, that is hip joint, knee joints, and heart valve replacement, vascular blood vessels grafts, fracture fixation devices, dental restorations, and generation of new organ tissues. Next, smart material. Smart materials have properties that react to changes in their environment. This means that one of their properties can be changed by an external conditions. Due to external condition, they change their properties itself. So it's more useful, such as temperature, light, pressure, electricity, voltage, pH value, or chemical compounds. Further discussion. Smart or intelligent materials are group of new and state-of-the-art materials now being developed that will have a significant influence on many of our technologies. The adjective smart implies that these materials are able to sense changes in their environment. and then respond to these changes in predetermined manners. Traits and are also found in living organisms. In addition, the smart concept is being extended to a rather sophisticated system that consists of both smart and traditional materials. Smart and traditional materials. Four types of materials are commonly used for actuators: shape memory alloys, piezoelectric ceramics, magnetostrictive materials, and magnetological fluids. Materials or devices employed as sensors include optical fibers, piezoelectric materials, and micro electromechanical systems. These are important in smart materials. Next, nanomaterials. Nanomaterials can be defined as materials possessing at minimum, that is one external dimension measuring 1 to 100 microns. Within the 100 microns, the very less, that is microscopic level. The definition given by the European Commission states that the particle size of at least half of the particles in the number size distribution must be 100 nanometers or below. One new material class that has fascinating properties and tremendous technological promise is the nanomaterial, which may be any one of the four basic types, that is metals, ceramics, polymers, or composites. However, unlike these other materials, they are not distinguished on the basis of their chemistry, but rather their size. The nano prefix denotes that that there is a 10 power minus 9 meter. Prior to the advent of nanomaterials, the general procedure scientists used to understand the chemistry and physics of materials was to begin by studying large and complex structure and then investigate the fundamental building blocks of this structure that are smaller and simpler. Some of the physical and chemical characteristics exhibited by matter may experience dramatic change as particle size approaches atomic dimensions. For example, materials that are opaque in the microscopic domain may become transparent on the nanoscale. Some solids become liquids, chemically stable materials become combustible, and electrical insulators become conductors. Furthermore, properties may depend on size in this nanoscale domain. Because of the unique and unusual properties of nanomaterials are finding niches in electronic, biomedical, sporting, energy production, and other industrial applications. Some are discussed as catalytic converters for automobiles, that is materials of importance in automobiles, nanocarbons, that is fullereness carbon nanotubes and graphene, particles of carbon block as reinforcement for automobile tires, magnetic nano-sized grains that are useful for hand disk drives, magnetic particles that store data on magnetic tapes. Whenever a new material is developed, its potential for harmful and toxicological interactions with humans and animals must be considered. Small nanoparticles have exceedingly large surface area to volume ratios, which can lead to high chemical reactivities with other elements. Although the safety of nanomaterial is relatively unexplored, there are concerns that they may be absorbed into your body through the skin, lungs, and digestive tract at relatively high rates, and that some, if present in the sufficient concentration, will pose health risks such as damage of DNA or promotion of lung cancers. Even that is, nanomaterials have more advancement and useful. Also, it has some bad effect to human bodies also. Research will go to rectify that damage of the human bodies because of the nanomaterials. Modern needs of modern material. In spite of the tremendous progress that has been made in the discipline of materials, science and engineering within the past few years, technological challenges remain, including the development of even more sophisticated and specialized materials as well as consideration of the environment impact of materials production. A number of a number of today's important technological sectors involve energy. There is a recognized need to find new and economical source of energy, especially renewable energy, and to use present resources more efficiently. Materials will undoubtedly play a significant role in this development. For example, the direct conversion of solar power into electrical energy without storing the electricity by batteries. Solar cells employ some rather complex and expensive materials. To ensure a viable technology, materials that are highly efficient in this conversion process yet less costly must be developed. Significant quantities of energy are involved in transportations, reducing the weight of transportation vehicles, automobiles, aircraft, trains, etc., as well as increasing engine operating temperatures will enhance fuel efficiency. New high strength, low density structural materials remain to be developed, as well as materials that have higher temperature capabilities for use in engine components. Nuclear energy holds some promise, but the solution to the many problems that remains necessarily involve materials such as fuels, containment structures and facilities for the disposal of radioactive waste. The roles that materials scientists and engineers play relative to these, as well as other environmental and social issues, will be discussed later. We have done. Please subscribe our YouTube channel.